So now, continuing with our coordinate geometry, we'll look at some shapes that you make out of straight lines and that can appear in problems. And we'll start off with an easy one, the triangle. And if they're nice, they might give you a right-angled triangle. And that would tend to be rather easy, and just there are different problems you can get, but and obviously I can't tell you it's impossible to tell you exactly what's going to be in the exam. I have no way of knowing that. But what I can tell you is give you a few hints that might help you to attack any problem that you're given. Just pretend this is a right angle. It's not, but close enough. If this gradient here is m, then this will have a gradient of -1 over m, right? Because it's the negative reciprocal. And so that may be helpful. And the area will be this. Let's call this a height, and this is the base, and the area will equal to half base times height. And remember, this b will be y2 minus y1 squared plus x2 minus x1 squared, all of that square rooted between these 2 points, and then it's the same thing between these 2 points for h. Then if you got a sort of another triangle, and you could be, another thing you can get asked is like figuring out, you're given 2 points and you have to figure out the third point, given sufficient information. If you just remember for a right angle one, remember that you've got perpendicular gradients, and you remember your distance formula, I reckon you'll be fine. But then a different triangle, I'll just remind you of the different types of triangles. My spelling's going to be challenged here. Isosceles looks close enough. That's got 2 sides of equal side length. And then equilateral is 3 equal side lengths. And then you've got, if you talk about things in terms of angles, such as an acute triangle, all angles are less than 90 degrees, or an obtuse triangle, one angle's above 90 degrees. Oh, and then the other one, in terms of side lengths, is scalene, 3 unequal sides. And in a case like that, maybe it might end up something like this. And I think that's fairly scalene. And perhaps it would give you some gradients and some points. It would give you sufficient information, i.e. 2 of the points, and you have to find out the third, or some combination of sufficient information. And so the ones you want to remember for that is your gradient formula, maybe your distance formula, and just remember that try to do like y2 minus y minus 1 equals, y minus y1 equals mx minus x1. That will probably be quite helpful. And additionally, try to replace as many variables as you can. Like, for example, if you are given the fact this is y equals 2x plus 1, and you know this is minus 2 minus 3, I think, that would add up. And then this was point A, comma B. Don't leave it as A and B. Call it A and 2A plus 1. So that's another point of advice I could give you there. And then you'll see examples of weird triangle problems later on when we do practice questions. But additionally, in also going area, it's a bit difficult to do a half base times height or half AB sine C. So what we have to imagine is, okay, let's call this -2, 3, -3. Call this 2, -5, and this is 1, 4. Let's, if I draw some dotted lines around here, I get a bit of a rectangle, don't I? And if we mark these points, this is -2, 4. This is -2, -5. And so we've got our four corners. So the area of rectangle is equal to... I do apologise, I make some dumb mistakes here, and I will realise a bit later on in the video. So just bear with me for now. 4 minus -5. So that's 6 times 9, which is 54. And now what we can do to get that area of the triangle is just subtract these three triangles away. So we'd say the area of the triangle is equal to 54 minus, and remember we do our half, this is where our half base times height comes in, because now we've got nice right angled triangles. We don't have to use trigonometry to find out the height. So if I just rub out these lines here just to make it easy to read, minus half times our base here, we'll do part A first, A, B and C, we're doing A first, times -2 minus -2 times -3 minus -5, and then we do minus half times, we'll do the B one now, so that would be, sorry, oops, I've bungled something up a bit, I think, that's 2, 4, here. Four minus -5 down here, then this needs to be, I do apologise, 2 minus -2. So that is 9 times 4, which is 36. Apologies for that. That is not aura. And then we'll keep going. B, and then we go our height. Our height, we'll do our height first maybe, or a base, it doesn't really matter. I would suggest probably it's a good idea to be consistent though. That's I think a really good way to approach it, be consistent. So we'll do the base first actually. So go 1 minus -2 times 4 minus -3. And we finally minus half times 2 minus 1 times 4 minus -5. And then that will be, so half times 4, which is 2, times another 2, which is 4, minus half times 3, so 3 over 2 times 7 is minus 21 over 2 minus half times 9. 6 minus 4 minus 15, because 21 plus 9 is 30, 30 over 2 is 15. Taking away 19, that leaves us 17, I think. And that would be units squared. And now we'll move on to, those are your triangles, stuff you could get there. There are, just remember those things we talked about in the last video, gradients and stuff, and then triangles will be very easy for you. And just remember this technique of maybe forming a rectangle, then just taking away the triangles. Now we'll move on to quadrilaterals. So quadrilaterals is stuff with 4 sides. So the easiest would be your squares and rectangles, because, well, for a square, you know, everything's got to be equal length, and it's perpendicular as well. Imagine that's a square, it's not a great square. So yeah, all equal in length, all only 90-degree angles that you're dealing with. And then it's quite similar for a rectangle. The whole point is, I mean, you've got these parallel lines, 2 sets of parallel lines, and one set is perpendicular to the other, and these two are equal in side length, these two are equal in side length. That makes it very easy. You just remember these will have the same gradient, but these will have the negative reciprocal. Those will be very easy, and remember your area is equal to, if you call this A squared, and the area here is, if you call this B and you call this H, equals base times height. That's very easy. I've no doubt you'll be able to do those. If you need to find points, I would suggest perhaps the easiest way would be make a perpendicular line through one point and then see where it cuts that one. It will make sense in the context of the question, but just think about perpendicular and parallel gradients. That's probably the easiest one. And additionally, maybe distance might come into it, because you've got those same side lengths involved. The next quadrilateral we will be talking about is the parallelogram. And a parallelogram is just something with a quadrilateral with 2 pairs of parallel sides. And so obviously you can instantly see, well, with 2 sets of parallel sides, that's instantly helpful, because, you know, parallel gradients can help with that. But then you've got to, what if you were given 3 of these points and you need to find this one? Now what you could do is formulate equations of lines and then figure it out algebraically and lengthily like that. Or you could very easily take the midpoints, know that these midpoints are equal. The midpoints of diagonals are equal. You'll see an example of this when we do practice questions later, but that's just what I want to leave with you for now for parallelograms. The midpoints of the diagonals are equal. And another thing, if you want the area, you would need to do this height times this base. And so if you really had to, I highly doubt they'll ask you to do that, what I would do is get a perpendicular line, which will have if this has gradient m, this will have gradient -1 over m, through this point, find where it intersects the other one, then do a distance between here and here, times it by that base, which is a distance between here and here, if that makes sense. That would be your area. Oh, and I'll just say perimeter. I highly doubt they do it because it'd probably be too easy, but you just do the distances, the lengths of every line and add them up. Very simple. Now we'll move on to a rhombus, and this is just a quadrilateral with 4 equal side lengths. This isn't a very good rhombus, but it'll do. Okay, that's slightly better. And so one thing that can be helpful is, yes, these are all the same side length. So the distance between each point, like here to here, and here to here, and here to here, and here to here, will all be the same. Additionally, you got the same thing again with midpoints of the diagonals will be equal. And area will be half of the, if we call this entire thing A and this entire thing B, it'll be AB over 2, I believe. Yeah, because if you think about it, you could honestly rearrange these into a rectangle, so you could shift this bit down here and then this bit down here, and you'd get left with half B but still a length of A along there. And then another example of another type of quadrilateral is a kite. And it kind of looks like this. And essentially the midpoint, again, not quite the midpoint, sorry. These diagonals, well, they should if it's an actual kite. Just pretend that it is a real kite, and these are 90 degrees. The diagonals are at 90 degrees to each other. And for area, we can do the same thing as we did with the trapezium, move some triangles around. And so if we call this P, and then this is Q, then the area is PQ over 2. And so I will again say that perhaps if you were trying to find the last point on a kite, what I would be thinking about is the perpendicular lines. And the last quadrilateral that we will look at in this video is the trapezium. And that's a quadrilateral with one pair of parallel sides. It could look like, if you pretend those are parallel, it could look like that. And if they're nice in the exam, they might give you a right-angled one. Like that. And essentially, if you were to take an average of that A and B, that gives you an average base length, which you can just times by the height for the area. And it's even easier here because you just got the height AB. And again, as I said with the parallelogram. If you want to find this length, get a perpendicular line, which will have a gradient of -1 over m. Find where it intersects and take the distance between those 2 points. But you could also do the technique where you make a rectangle, then minus off some triangle areas. That would work. Anyway, so those are some shapes. It's rare that these sort of things come up in the exam, but sometimes if it's in there, it can really trip people up who just haven't gotten around to looking at it.